Hydrocarbon exploration is the search by petroleum geologists and geophysicists for hydrocarbon deposits beneath the Earth's surface, such as oil and natural gas. Oil and gas exploration are grouped under the science of petroleum geology. Exploration methods. Visible surface features such as oil seeps, natural gas seeps, pockmarks provide basic evidence of hydrocarbon generation. However, most exploration depends on highly sophisticated technology to detect and determine the extent of these deposits using exploration geophysics. Areas thought to contain hydrocarbons are initially subjected to a gravity survey, magnetic survey, passive seismic or regional seismic reflection surveys to detect large-scale features of the subsurface geology. Features of interest are subjected to more detailed seismic surveys which work on the principle of the time it takes for reflected sound waves to travel through matter of varying densities and using the process of depth conversion to create a profile of the substructure. Finally, when a prospect has been identified and evaluated and passes the oil company's selection criteria, an exploration well is drilled in an attempt to conclusively determine the presence or absence of oil or gas. Oil exploration is an expensive, high-risk operation. Offshore and remote area exploration is generally only undertaken by very large corporations and national governments. Typical shallow shelf oil wells cost $30 million, while deep water wells can cost up to $100 million plus. Hundreds of smaller companies search for onshore hydrocarbon deposits worldwide, with some wells costing as little as $100,000. Elements of a petroleum prospect. A prospect is a potential trap which geologists believe may contain hydrocarbons. A significant amount of geological, structural and seismic investigation must first be completed to redefine the potential hydrocarbon drill location from a lead to a prospect. 4 geological factors have to be present for a prospect to work, and if any of them fail, neither oil or gas will be present. A source rock. When organic rich rock such as oil, shale or coal is subjected to high pressure and temperature over an extended period of time, hydrocarbons form. Migration. The hydrocarbons are expelled from source rock by 3 density-related mechanisms. The newly matured hydrocarbons are less dense than the precursors, which causes overpressure. The hydrocarbons are lighter, and some migrate upwards due to buoyancy, and the fluids expand as further burial causes increased heating. Most hydrocarbons migrate to the surface as oil seeps, but some will get trapped. Reservoir. The hydrocarbons are contained in a reservoir rock. This is commonly a porous sandstone or limestone. The oil collects in the pores within the rock, although open fractures within non-porous rocks may also store hydrocarbons. The reservoir must also be permeable so that the hydrocarbons will float to surface during production. Trap. The hydrocarbons are buoyant and have to be trapped within a structural or stratigraphic trap. The hydrocarbon trap has to be covered by an impermeable rock known as a sealer cap rock in order to prevent hydrocarbons escaping to the surface. Exploration risk. Hydrocarbon exploration is a high-risk investment, and risk assessment is paramount for successful project portfolio management. Exploration risk is a difficult concept and is usually defined by assigning confidence to the presence of the imperative geological factors, as discussed above. This confidence is based on data and/or models and is usually mapped on common risk segment maps. High confidence in the presence presence of imperative geological factors is usually colored green and low confidence colored red. Therefore, these maps are also called traffic light maps, while the full procedure is often referred to as play-fairway analysis. The aim of such procedures is to force the geologist to objectively assess all different geological factors. Furthermore, it results in simple maps that can be understood by non-geologists and manages to base exploration decisions on terms used in petroleum evaluation. Bright spot on a seismic section coda that have high amplitudes due to a formation containing hydrocarbons. Chance of success, an estimate of the chance of all the elements within a prospect working, described as a probability. Dry hole, a boring that does not contain commercial hydrocarbons. See also dry hole clause. Flat spot, possibly an oil-water, gas-water or gas-oil contact on a seismic section, flat due to gravity. Hydrocarbon in place, amount of hydrocarbon likely to be contained in the prospect. This is calculated using the volumetric equation, Grove x Ng x porosity x sh, FVF Grove, gross rock volume, amount of rock in the trap above the hydrocarbon-water contact Ng, net, gross ratio, proportion of the grove formed by the reservoir rock, porosity, percentage of the net reservoir rock occupied by pores, sh, hydrocarbon saturation, some of the pore space is filled with water, this must be discounted, FVF, formation volume factor, oil shrinks and gas expands when brought to the surface, the FVF converts volumes at reservoir conditions to storage and sale conditions. Lead, potential accumulation is currently poorly defined and requires more data acquisition and/or evaluation in order to be classified as a prospect. Play, an area in which hydrocarbon accumulations of prospects of a given type occur. For example, the shale gas plays in North America include the Barnett, Eagle Ford, Fayetteville, Haynesville, Marcellus, and Woodford, among many others. Prospect, a lead which has been more fully evaluated. Recoverable hydrocarbons, amount of hydrocarbon likely to be recovered during production. This is typically 10 to 50% in an oil field and 50 to 80% in a gas field. Licensing. Petroleum resources are typically owned by the government of the host country. In the USA, most onshore oil and gas rights are owned by private individuals, in which case oil companies must negotiate terms for release of these rights with the individual who owns the OGM. Sometimes this is not the same person who owns the land surface. In most nations, the government issues licenses to explore, develop and produce its oil and gas resources, which are typically administered by the oil ministry. There are several different types of license. Oil companies often operate in joint ventures to spread the risk. One of the companies in the partnership is designated the operator who actually supervises the work. Tax and royalty. Companies would pay a royalty on any oil produced, together with a profits tax. In some cases there are also various bonuses and ground rents payable to the government. For example, a signature bonus payable at the start of the license. Licenses are awarded in competitive bid rounds on the basis of either the size of the work program or size of the signature bonus. Production sharing contract. A PSA is more complex than a tax royalty system. The companies bid on the percentage of the production that the host government receives. There is often also participation by the government-owned national oil company. There are also various bonuses to be paid. Development expenditure is offset against production revenue. Service contract. This is when an oil company acts as a contractor for the host government, being paid to produce the hydrocarbons.